Today's webinar is titled OEE, or Overall Equipment Effectiveness, and its impact on productivity. Presenting the session today is the founder and president of CTPM, Ross Kennedy. Since CTPM's establishment in 1996, Ross has developed an improvement methodology that is centered around progressively developing and engaging all personnel to identify problems at the earliest possible time, solve them to root cause, and share in the learning. Over this time, Ross has become recognised as Australasia's leading authority on total productive maintenance and CTPM's Australasian TPM lean approach to operational excellence. So with that being said, let's get started with today's session, and I'll now pass you over to Ross.
Thank you, Nelson, and welcome everyone to our webinar today on OEE and its impact on productivity. I'd like to thank our member who put forward this topic. We always love to get feedback from our other webinars and new ideas for topics. We're also pleased, I was quite surprised, I guess. We have quite a big audience registered today, apart from people throughout New South Wales, Queensland, Victoria, South Australia and Western Australia, and our colleagues from New Zealand. We also have quite a large contingency from India, Pakistan, Philippines, Singapore, Iraq, Qatar, USA, Mexico, Venezuela, Zambia, Nigeria, South Africa, UK, and Macedonia. So obviously this topic has resonated with a few people. So what we want to do is try to talk about equipment effectiveness and people performance, the impact people can have on equipment effectiveness, the impact equipment can have on people performance, how best to measure and monitor the impact people have on OEE, and the importance of a team-based improvement approach. So to start with, we will get that going. I thought just to put this into context of our 4 key parts of an operational excellence improvement journey, which is leadership, reactive improvement, stable production plan, and proactive improvement. What we're talking about today is some of the activities and focus of our proactive improvement, which is our hamburger model, and it's got the area that's probably the biggest focus when you first initially start looking at OEE and productivity in a production environment. You would look at focus equipment and process improvement, which is a cross-functional team, and then later on you'd move on to the work area management and operate equipment management activities, which are area-based, production area-based teams. But overall, it's not only the production area, but it's the support areas that also have a big impact on OEE and productivity. So it does cover a fair bit in this area. So let's get started with the equipment effectiveness and people performance, and start off with equipment and overall equipment effectiveness. You've probably all seen the OEE model, which is about availability, rate, and quality, based on the premise that equipment is not effective unless it's there when you want it, running at the ideal rate, and producing perfect product first time. Now, in our model, we have the 7 big losses, unlike some of the early models of OEE when TPM was first, I guess, developed, where they didn't include planned downtime. What we've learned, and also the people who developed TPM, the Japan Institute of Plant Maintenance, or who recorded it, Nissan Denso or Toyota actually developed TPM, but they've now added the planned downtime in their model as well, because what we find is a lot of plants run more than one shift, and also there's a great opportunity there to impact on the output of the plant by managing planned downtime. So why is OEE improvement important for TPM and operational excellence? Well, we want to increase capacity, and every increase in percentage OEE should result in equal percentage increase in good output, or be able to make the same amount of good output in the less time. And that's why it's important to have the 7 big losses. We want to defer the need to introduce overtime or extra shift if demand increases. One of our clients, Cooper's Brewery, over in South Australia, since their journey, when we started, I think back in about 2003, in the early days, only running one shift, but they kept getting bigger and bigger demand. But by improving OEE, we were able to defer the need for the extra shift for quite a number of years. We also want to free up time for production area-based team improvement activities. And I spoke about work area management, which is our version or an enhanced version of 5S, and operator equipment management, or some people refer to it as autonomous maintenance, where production line may need to stop, especially while doing clean for inspections. So if you've got to stop your production line, you need to compensate that by increasing your OEE first. And that's why we start with focused equipment and process improvement cross-functional teams, which do not require the line to stop before you move into your area-based team activity, which if you don't do, you'll miss out on probably half the gain of improving OEE. So how do we calculate OEE? You can use what we call the time loss approach, where you start off with your available time and take away your downtime rate losses and quality losses, and your OEE is a value adding time over available time. What a lot of companies do is create what we call an equipment loss model, which is a little bit more detailed than what I just showed you, where you start with your theoretical time, which is if you're measuring for a week, that would be 7 days, 24 hours by 7 days, 168 hours, for example. Now, there will be no demand, and that would be, for example, you may not want to run your plant on the weekend. So you're running 5 days. No demand is a loss that is really dictated by your marketing and product development people, because they're the ones who will put demand on the plant. Got nothing to do with operations. Then you have special events, and we tend to identify those because that, again, takes up some time, and we normally take that out of the OEE equation. So special events might be new product trials, or you may have a major shut. So yeah, you might have regular monthly 8-hour shuts on your line for maintenance, but every 6 months or 12 months, you might have a extended 24-hour shut or something like that, which is a one-off event. So again, we pull that out of the equation, which means your OEE is available time with all the losses, and OEE is value adding time over the available time. The other way of working out OEE is using equations. So you have an equation for availability, you have an equation for rate, which takes into account reduced speed and minor unrecorded stoppages. And you then have your quality equation, which we often use a mass balance approach, good output produced over processed amount. And by having those three measures as percentages, you can create your OEE by multiplying availability by rate by quality. And what we've done in our training is we get people to calculate OEE using the time loss model before and the equations, and you should come up with the same result if you're doing it correctly. Now, there's a simple way of calculating overall equipment effectiveness using what we call the high-level equation. Again, the high-level OEE can be calculated by multiplying the availability, the rate, and the quality equations and reducing the common parts. So if it's on the denominator, on the numerator, on more than one equation, you can pull it out. And the following comes up with the following simple formula. Now, just to explain that a bit more detail, with availability, for example, you'll see those in color, like the blue and the blue crosses out, the purple and the purple crosses out, the red and the red crosses out, and you end up with your good output produced over available time times ideal rate. And that's what we call the high level equation. And obviously when you create an equation, you have definitions for what do we mean by available time, what do we mean by ideal speed. Now, what's the advantage of a high level OEE? Well, when we go into sites, we often find that they are graphing their OEE performance based on their recording system, whether it be automated or manual. And what we do is go and look at using the high level equation, because we know that is the most accurate way of measuring OEE. It doesn't tell you where the losses are, but it's the most accurate method. And this is at one site we're working at where they were reporting that their average OE was 71%, which is the blue line. When we worked out the high-level equation, they were actually missing a number of losses in their methods of calculating or capturing information, and they were actually overstating their OE by 9 percentage points, or 13%. And that's quite a lot of, if you go get 13%, you can go understand you're missing that, and you start searching for it and doing things about it, it can be quite a significant improvement. So what about people performance? We've talked about equipment performance. Let's talk about people performance. That's normally productivity. Now, productivity can be measured in two broad ways. One is what we call company productivity, which is the total sales dollar value over the total number in the workforce. Now, Cooper's Brewery, again, I mentioned earlier, used this as one of their measures. And I know when we first started in 2003, that figure was roughly $500,000 sales per employee. Now, or in the last year or so, when the operations manager gave a presentation, he was talking about now they're generating, or their productivity is about $1 million sales for every employee. Now that covers the whole company, but it is a productivity measure, and obviously has a lot to do with your product development, your marketing, to improve the productivity of the total workforce. From an operational perspective, productivity is more often measured on the basis of good output produced over the total hours worked, or the total hours you put into the production line or production area. An example, one site we're working with, they used to record this. Now, this was a interesting operation, because they're actually putting printing as a printing area, printing logos onto safety helmets. And you had a number of different printing machines. They all had different parameters and ran different ways, and they all had different mixtures of numbers of colors they could put in a logo, and how many logos you went on the helmet. So they were capturing what they were doing, but that information was pretty much useless unless you started relating it to a particular product. And that's sometimes one of the issues with productivity. So comparing OE and productivity, our measure for OEE, we said, is good output produced over available time times ideal speed, and that's all about the machine, the available time and ideal speed of the machine. Operational productivity is the same good output produced, so you've got this common factor. However, underneath, it's got nothing to do with the machine. It's how many people went into producing that output. Now, this is where they are quite separate measures, and hence you need to measure both. OEE will not reflect on the people input. It is not designed to reflect on people input unless, of course, you're adjusting the ideal speed, because your ideal speed is the best possible speed you can get out of the machine. Now, if you've got a machine that is influenced by the number of people, for example, if you have a line where if you have extra people at the end packing quicker, the line can produce more. Then if you're manning it with, say, 4 people in the packing area instead of 3 people in the packing area, your ideal speed changes. And that will reflect a bit in your OEE. But that's becoming quite a complex little exercise. And a lot of companies, this is where I guess we've got to look at what is the situation that you're actually measuring. What is the line? What's the characteristics of the line or production area? And that leads on to, in our online training course, or used to be our 2-day public workshop, we talk about the limitations of overall equipment effectiveness. And this is a slide taken from that course where it says OEE is a key improvement driver. So it's not a measure that you use to compare machines or compare performance between machines. It is there to help you improve the performance of the machine you're running or you're looking at. However, the key success factors for operations through goal line performance measures need to be monitored to ensure they improve rather than be decreased to achieve short-term gains in OEE. Now, that's our model that we use for measurement. And what that is basically saying from a cause-effective perspective, the reason you're in, for example, running a site, a manufacturing company, for example, is to get a return on investment. If you don't get a return on investment, in other words, financial performance, people won't invest in the site or they'll close the site down. So what you're interested in from an operational perspective is what are all the factors that will impact on you achieving your financial performance, or most importantly, not achieving it. And they're the factors that we've found. If you have accidents, if you don't get it right first time, if you don't satisfy the customer and deliver what you should, the equipment doesn't run perfectly, if people aren't productive and turning up, if suppliers let you down and you have the wrong inventory, it's going to have an impact on your financial performance. So that's the measurement model we look at. And if we just think about the implications of some of those factors, for example, safety, health, and environment, you want to measure that to ensure people aren't doing unsafe tasks to improve performance. In other words, taking risks to get more good output. And that would affect both your productivity and your OEE. Quality, to ensure we do not lose sight that quality is the most expensive of all the losses and waste, especially when you're measuring OEE. For example, again, a slide out of the online course or our two-day workshop. We put this slide up and say, okay, you can have two situations. When you're measuring OEEs, we said earlier, availability times rate times quality. So you could have an availability of 90, a rate of 95, and a quality of 99, and that would multiply it out, you get 85%. You could also have another situation where your availability is 99%, your rate is 95, but your quality is only 90. In other words, 10% of what you make you're throwing in the bin, right? Or having to rework. You've still got 85% OEE, but which situation is best for the company? Well, in most cases, situation one is much better because you're not throwing away 9% of your raw materials or your products that you have added value to, right? Whereas in situation one, yes, you're not running the line 10% of the time, but you're not wasting any product. Situation two, you're wasting a lot of materials. So that's why maintaining and improving such things as rework and process waste and scrap is critical to really focus on. So again, you've really got to understand the elements of OEE, and again with productivity when you're trying to measure good output. So other things, customer satisfaction, to ensure that there are no downstream customer complaints, which would result from a strong focus on getting product out to achieve a good OEE result. And I've seen situations where people make products and they move them out and they go into storage. Or in one case, we had a site where they'd made a cement board and it went over into an autoclave and cooked for 24 hours. Then it came out and went on the finishing line. But they, to improve their OEE, they sped up their line, which put ripples into the board. So when it went to the finishing line and had to be sanded smooth, there was a lot more work involved, right? So you had OEE looking good, but customer downstream finishing area were not impressed. But that doesn't get shown up on your OEE measure. It's shown up as a internal customer complaint. Plant equipment. To ensure good output correlates to OEE, so all losses are being captured. We've talked about that. People, to ensure more people aren't allocated to an area to compensate for problems affecting performance. And again, I've been in a site where they're making, for example, butter, little blocks of butter. And on the machine, they'd bring, the block would come in, they'd carve it up, and they'd wrap it up in a foil special label, and they'd wrap it, and then they'd fold in the ends on the block, and it would go off to be packaged. Well, what happened at this line was the machine that was folding the ends, one side of the machine, there was a fault in the machine. So rather than stop production, they put a person extra on the line whose job was to simulate what the machine did, in other words, fold the end of the block as it went past. So by the end of the day, the OEE was good. The line didn't stop, the line made the output. However, if you're measuring productivity, your productivity was down because you had an extra person on the line. And this is where you've got to measure both. You can't just look at one of them. So what impacts on good output produced, which is a component of productivity and a component of OEE? Well, you can have technical issues, equipment breaking down, for example, right? Whether it be major unplanned recorded downtime or minor little stoppages, and that can be for things going wrong with the equipment, right? And that will impact on how much good output you produce. People issues, operators aren't properly trained. They will tend to run slower than those who are fully trained and confident and have the experience, right? Or they will do things that will result in little stops and which they have to go and adjust all the time because they're not adjusting things correctly in the first place. You can have supplier issues where your materials coming in or your packaging materials, we've seen that quite often, not being really, might have too much humidity in it and it's not working well in the machine and often jamming up or having to be rejected. You can have planning issues where you set up downtime, so you keep swapping the production plan around and all of a sudden you've got to swap and start making something else, and then you've got an extra setup, and you're not ready for it and you're losing time. And management issues. Do we have a maintenance period every month for 8 hours, or do we have a 1.5 hour clean for inspection on our line and do our maintenance work then, or 2-hour one every week? Right? And again, the way you go about doing that can have an impact on how much downtime you use, the strategy you use for maintenance, and again, whether you have extra people to hot seat or run the plant while people have a break. So those issues can all impact on OEE and productivity. So the other thing we've got to think about is what are we actually measuring? And I was touching on that because you have different situations in different plants, and you also have different situations in the same plant. You can go to one area to another area. So you might have a production line with various workstations. So it might be a filling line, filler, labeler, packaging, palletizing, right? And you might just have one operator working like a big molding machine where they're trimming and feeding in, etc. And you're measuring the OEE on that, or you're measuring the productivity on that machine. You might have an assembly, packing, sorting operation with various workstations, and you may have various manning. And like processing fruit, for example, or vegetables on a sorting line, depending on what's coming in and what the contamination is like in amongst all the packaging, all the product, depends on how many people you need there sorting, right? A manufacturing cell, where the number of operators is dependent on what we call takt time or demand of the customer. So if you have a big demand, you might have 3 people working in the cell. If there's a low demand, you might only have 2 people working in the cell. You have a fixed input, batch-driven production line, where you make up a batch and then you run, and that's the end of the day. And if you run early, finish early, that's great, but what happens to your OEE, the people standing around? Is that do you say OEE take a hit, or do you have an extra measure in there? For example, or you might go over and you've got to work overtime. Then you've got fixed output, like what we call daily fresh, making bread. People ain't wanting the amount of loaves per day, or printing newspapers. You only want a certain number. And again, different scenarios. So all these scenarios need to be well thought out in putting together what's the best way to measure what we're doing. And the other thing is that supports all this is having a very effective daily review meeting each day. And a tier 2 meeting is typically the supervisor's meeting with the leading hands or the frontline leaders. And in this example, you've got 3 areas. So you have a supervisor with 3 frontline leaders who would report on their performance. And on the left-hand side, you've got your key success factors, and on the right, you've got your measures. Now, if you look at the measures, the quality ones are there to pick up on the quality elements because that's so critical. Under customer satisfaction, obviously, amount of good output achieved, because that's what you need to work out OEE and or your high-level OEE and your productivity figure. Achievement of plan, obviously, unplanned downtime, an element of OEE. Your high-level OEE equation, Then you've got your labour hours, and that would allow you with labour hours and good output to work out your productivity. And then you've got other disruptions such as supplier or inventory. So that's an example of a pretty good comprehensive daily review meeting process where you're starting to bring all the measures together to give you a full picture of what's happening out there. And just moving on to the last point, the importance of a team-based approach. We are very, very strong on what we call ongoing improvement, where it is team-based. So people are growing and developing in a team environment, and it's about getting everyone to do, for example, 5% of their normal work time in an improvement team all the time, part of their job. And as I mentioned earlier, the area we start when we start analysing losses in a production line would be our macro-focused equipment and process improvement team, where you'd have the area supervisor leading the team. Very important for them to lead because it's their area, their ownership to the area. You'd have if you're multi-shift, you'd have one, for example, leading hand or frontline leader and an operator. You'd always have people from the same shift so that people aren't working overtime when you have your meetings. You'd have maintenance response, either one or two maintenance people, or technical support people, one or two, whether it be a planner, a quality person, project engineer, whatever. And you try to get a manager on the team to be a team member, not lead it. And you normally would have that team properly facilitated by your own internal resources or use external facilitators like CTPM. So what we're doing is that's the starting point. And you're using a 9-step structured process, which is well proven, using plan, do, check, act, recognizing as you progress, there's some iterations. If things don't actually get the outcomes you want, you come back and you recycle. So it's not just a straight linear process, it's an iterative process. The key to it is getting very good analysis. And what we normally do is on the left-hand side is the sort of analysis your facilitator would do to support the team to start before you start or in the first week of the team. And you'd use that information to feed into the team. But the most important thing for the team to focus on is getting all the operators' input into where the issues and frustrations are, getting a good understanding of what the quality system of standard operating procedures, etc., quality standards are like. Then your Oee analysis, which involves observations and going down and doing observations of the line in a relay approach to get an understanding of all the minor little stops, etc. Cost reduction, other losses, including productivity. So you start looking at the people side. You can then put a pretty holistic picture together of what's happening out there and where the opportunities are. So in, I guess from our TPM perspective, that we use this model to explain to people what's required if you want to go down the TPM journey. And we say you've got to do preparation to free up production time, you've got to do maintenance capability to free up maintenance time, you've got to do production capability, so you've got the required discipline for your production area-based teams to get involved with the autonomous maintenance or operator equipment management activities to achieve TPM excellence. And if you don't go in that sequence, what happens is it just doesn't work. And I've seen many, many examples where people just dive straight into, oh, let's do autonomous maintenance without doing all the prep work. What I've been talking about today is this initial Oee improvement, which is also looking at productivity as well. So hopefully that's been of some help to you. I've gone through it pretty quickly, but I think it's given you a flavour of some of the issues you need to consider. How can we help? The reason I wrote my first book on understanding, measuring, and improving overall equipment effectiveness is to help people understand what I've been talking about in a lot more detail and take you through that, how to get an improvement team and how to develop what we call an Oee improvement matrix and the spreadsheet to really drive improvement. The other thing I've mentioned today is the online self-paced accredited yellow belt training course, which is available. If you go to our web page, you'll find out about it. We've had quite a number of people, especially with the COVID situation, doing that course because it's self-paced, and finding it very, very helpful. We have our site membership, and we have our site subscription, which Nelson mentioned at the very start. At the moment, with the site subscription, we've actually got a special deal on of 25% discount, simply because this is our 25th year. So 31st of December, that stops. But if you get in quick, you can get a saving. And with that, I don't think I've used up my time. It's about questions or comments. Now, I'd like to thank those who, when they registered, they put in some questions for us. So while you're thinking about your questions or putting your questions to Nelson for me to have a talk about, we did receive 5 questions from one from Michael from over in South Australia, one from Surab from India, one from Ashok from India, one from Mario in the Philippines, and from Albert. So very quickly going through those, what's the best way to calculate OE for a cell that runs different batch jobs over 10 over 3 shifts based on volume, etc. Now your challenge there is your ideal speed, because when you're running different batches of different jobs may have a certain rate or ideal speed that you need to run. Now, what we did at Camelco Rolled Products many years ago was introduce what we call equivalence. So we said, and their scenario was they're running different blocks of aluminium through a rolling mill. So some blocks were hard aluminium, some were soft aluminium. So every job we gave it is either an 0.6 because it went through really fast, or it was a 1.5 because it was really tough to put through, or it was a 1 if it was a standard type batch. So yes, there's different ways you can approach that. With the second question, what is the ideal team size for Jushin Herzen, or autonomous maintenance? That's the Japanese word for it, for non-production areas. Now, when you do autonomous maintenance, we've found the only way it's going to be really successful is it's got to be team-based, the production area-based team. Everyone in the work area on each shift, you go all shifts working in concert to do the same, clean for inspections, etc. And we find an area-based team should be no more than 8 people, including a frontline leader. If you're any more than that, you don't have an effective area-based team. So teams just fall apart after you go past 8. So we always look for a size of team of about 4 to 8, which includes a designated frontline leader. The difference between JH circles or autonomous maintenance circles and PM circles, PM is maintenance, preventive maintenance circles. Again, we tend to use either cross-functional teams for preventive maintenance can be a cross-functional activity, whereas a autonomous maintenance has to be a production area-based team activity, which is supported by a dedicated maintenance support person. Ashok, in case of batch process, which is having a lot of manual intervention, how can we improve OEE? Again, I would suggest you go through that detailed focused equipment and process improvement process and really understand exactly all the losses and work out what is the proper ideal measures to use, have an effective daily review meeting to monitor your progress, and based on the outcomes of your cross-functional team, hit the low-hanging fruit to start with and put a plan together of what needs to be done from a technical perspective and what needs to be done on a people development perspective. Mario, what is most important in manufacturing the OEE performance or productivity result? Hopefully you've got the message today that you need to measure both, because they're both different. One's relating to people, one's relating to machines. And you can fiddle with both. So unless you keep an eye on both, productivity might get OEE up, productivity might go down because you put more people on the line. So that's why you really need to measure both. And the last one from Albert, what is the best OEE for batch type process, start-stop system? Again, what we find is you have your batch and you have a time to empty out that batch, make that batch. So you have your crew time, but you need to introduce a measure of no production required because we've finished the batch. So that if you finish the batch an hour early, your OEE looks good, but you have that 1 hour no production due to batch completed. You've then got to look at, how do I use that 1 hour? Either I increase the batch sizes and reduce it, or I use that time to do autonomous maintenance or other improvement. So I hope that's given very quick answers. Happy to further those answers if you wish, by either contacting me or sending me an email. With that, I don't know if there's any other questions.
No, I haven't seen any come through. We just had Ashok sent a little note just saying thank you for answering his questions. So that was nice. We haven't got any others through. I think you answered quite a few questions there. If we'll just wait a little bit longer, and just a reminder to everyone that a recording of the webinar will be available in a follow-up email this afternoon. So please feel free to watch it again or share it with your colleagues. It doesn't seem lost. I think we might close off the session here. So that brings us to an end of today's webinar. We hope you took some learnings away from the session. We encourage you to complete the feedback form after the session to let us know how it went, and if you have any topic suggestions for future webinars. Thank you again, everyone, for attending, and we hope you enjoy the rest of your day. Bye for now.
Bye, everyone.